So the topic we are about to discuss is coplanarity of two lines. Basically means that what is the condition for two lines to be coplanar? They can lie in single plane. So suppose we have a plane in here and we have two lines and they are lying on the same plane. So the first line, the equation of the first line goes like r vector is equal to a1 plus lambda b1, and that signifies that there is a point on this line whose position vector is a1 vector, and this particular line L1 is parallel to a vector that is b1 vector. Then the second line, that is the equation of the second line, that is given by r vector is equal to a2 vector plus mu b2 vector. So for this case, the position vector of the point is given by a2 vector and the vector which is parallel to the given line is b2 vector. So these are the things which have been given. The two lines are given and you have to prove that these two lines are coplanar. So in order to do, what we're going to do is, first we're going to join the 2 points. Suppose this point is A and this point is B. So we're going to join the 2 points and we'll get an AP vector. And that AP vector is nothing but terminal minus initial. So we get that one as A2 vector minus A1 vector. So once we get AP vector, so for that line, for the two lines to be on the same plane, what we need is a perpendicular vector to both the lines, and that perpendicular vector will also be perpendicular to the plane in which the two lines lie. So in order to get that perpendicular vector, what we're going to do is, we have two parallel vectors in here, b1 and b2, and while studying vectors you have learned there was one way in which we can get a vector which is perpendicular to a plane in which two vector lies, and that is by doing cross product. So if you have a plane in which a and b vector lies, then in order to get a vector which is perpendicular to both a and b, sorry I made a mistake in there, so theta, this one is a, this one is b. So in order to get a vector which is perpendicular to both a and b, what we do is we find a cross b. So we do the cross product of the two vectors. So in here also, in order to get that perpendicular vector which is perpendicular to both the two lines and the plane in which the line lies, so we're going to do b1 cross b2. So b1 cross b2, the direction of it will be perpendicular to the plane. Okay, so here, and that b1 cross b2, since it is perpendicular to the plane or the both of the lines, so we can see that it is also perpendicular to the AP vector. And since it is perpendicular to AP vector, in dot product of chapter vector algebra we studied that dot product of two vectors is 0 when the two vectors are perpendicular to each other. So here AP vector and b1 cross b2 are perpendicular, so their dot product will be 0. So we write b1 cross b2 is perpendicular to AV vector, so AP vector dot b1 cross b2 is equal to 0, and AP vector we already got, that is a2 minus a1 dot b1 cross b2 is equal to 0. So this is the condition for two lines to be coplanar. So this a2 vector you get from the equation of line 2, a1 vector you get from the equation of line 1, and b1 is the parallel vector of line 1 and b2 vector is the parallel vector of line 2. So this is the condition which we use for coplanarity of two lines.